Let's understand the concept of the limit of a function. In this case, the question is find the limit of the function f of x when x is approaching to 0 and the function here is 1 over x. Now we will mark x values here, and for corresponding x values, the values of the function f of x will be marked here. First of all, let's see what is the meaning of limit of f of x when x is approaching to 0. So it says that when x is getting closer to 0, where is f of x approaching? Since we have to find the limit when x is getting closer to 0, so we are marking 0 here, and we have to approach towards 0 from the right of 0. We also have to approach towards 0 from the left of 0. Let's say we pick a value closer to 0 but on the right hand side of 0. We pick 0.002. It is closer to 0 but on the right hand side of 0. So when we plug 0.002 x value in the function f of x, and in our case the function is 1 over x, we get 500. 1 over 0.002 gives 500. Let's get closer to 0 by picking one more value, 0.001. In this case, when we plug this value of x in the function 1 over x, we get 1000. We can see that the values of the functions are getting larger. Let's say we pick one more value, 0.0001. In this case, the value of the function is 10,000. So we can see that as we get more closer to 0, the value of the function f of x will become larger. So we can say that when x is approaching to 0, on the right hand side of 0, we will denote this by putting a plus on 0. The function f of x, in our case this function is 1 over x. This function is getting huge. Let's say if you pick a value closer to 0, a very tiny value, let's say 0.0001, so you will get a very big f of x value. So we can say that when x is approaching to 0, on the right of 0, the function 1 over x seems to be approaching to a very big positive value, and let's say that very big positive value is plus infinity. Now let's get closer to 0 by picking some values on the left of 0. Let's say we pick minus 0.002. When we plug this value in the function 1 over x, we get minus 500. Let's pick a value closer to 0, minus 0.001. In this case, the function value is minus 1000. We can see that if x is getting closer to 0, the function values are becoming huge, but negative huge values. So we can write it that when x is approaching to 0, on the left of 0, the function value, in our case the function is 1 over x, function values are getting very big, but the negative big values, which is minus infinity. So this is how we find the limit of the function 1 over x when x is getting closer to 0. Please note that we have not yet calculated the value of the function exactly at 0. We picked some values on the right of 0. We picked some values on the left of 0, and we saw that what are the values of the functions that we are getting. Now let's find the value of the function calculated exactly at 0. Since our function f of x here is 1 over x, so f exactly at 0 is 1 over 0, and whenever there is 0 in denominator, that is undefined. So we can see that the right hand limit at 0, which is when x is approaching to 0 from the right hand side of 0, like here. This limit is plus infinity, and the left hand limit, meaning when x is approaching to 0 from the left of 0, that limit is minus infinity, and the value of the function exactly at 0 is undefined. So in this example, we are seeing that left hand limit, which is x approaching to 0 minus f of x, is not same as the right hand limit, which is x approaching to 0 plus f of x, and both of these values are not same as f calculated exactly at 0. This is how we understand the limit of the function at a point. Let's look at another example. In this example, we have a function f of x minus 1 over square root x minus 1. We have to find the limit of this function at 1. Please note that the limit of a function at 1 is different from finding the exact value of the function at 1. For example, let's say if you are asked to find what is the value of the function at 1, so what you will do is you will consider the function x minus 1 over square root x minus 1, and in the places of x you will put 1. This is what you do when you have to find the exact value of the function at 1. You can see that in numerator we have 1 minus 1 0 divided by square root 1 is 1, so 1 minus 1 in denominator, which gives us 0 by 0, and again 0 by 0 is undefined. So we can see that the exact value of the function at 1 in this case is undefined, which is 0 by 0. Now let's get back to finding the limit of the function at 1. So for this, we will mark the x values here, and we will mark the y values here, or f of x values. Since we have to find the limit at 1, so we will mark 1 here. So when x is getting closer to 1, it means x is getting closer to 1 from the right side of 1, and x is getting closer to 1 from the left side of 1. Let's pick one value closer to 1 but on the right hand side, 1.005. When we plug 1.005 in our function f of x, and function here is x minus 1 over square root x minus 1, we get the function value 2.004. Let's get closer to 1 by picking one more value, 1.001. In this case, the value of the function is 2.00049. We can see that this 2.004 is approximately 2. We can also see that 2.00049 is approximately equal to 2. So we can see that when x is getting closer to 1 on the right of 1, the function is getting closer to 2. Function value seems to be approaching to 2. Let's pick the values closer to 1 but on the left of 1. When we pick, let's say 0.98, which is closer to 1 but on the left of 1, we get the value of the function as 1.9899, which is approximately equal to 2. Let's pick one value closer to 1 but on the left of 1. This time we are picking 0.99. We can see that the value of the function at 0.99 is 1.9949, which is approximately equal to 2. Again, we can see that when x is approaching to 1, on the left of 1, the function seems to be approaching to 2. So we can write limit x is approaching to 1, the function x minus 1 over square root x minus 1 seems to be approaching to 2. So limit of a function x minus 1 over square root x minus 1 at 1 is 2, and we saw that f exactly at 1 was 0 by 0, which was undefined. So in this example, we have seen that it is possible that the exact value of the function at some x could be undefined, but the limit at that number could be defined, and in this particular example, the limit of the function f of x when x was approaching to 1 was 2, but f exactly at 1 was undefined. So this is how we understand the concept of the limit of a function at a point. Before we wind this up, let's look at the notations. When we say find the limit of a function f of x when x is approaching to a from the right hand side of a, this is denoted as a plus. So what is the meaning of a plus? That x is approaching to a from the right hand side of a. Let's say a is some number. A is 5. So 5 plus means that x is approaching to a from the right of 5. So you will pick x as, let's say, some number on the right of 5, maybe 5.002. You will pick some number closer to 5, maybe 5.001. So this is the meaning of a plus. If you have to find the limit of a function f of x when x is approaching to a but from the left of a, so this is denoted as a minus. So what is the meaning of this? That x is approaching to a but from the left of a. Let's say a is again some number 5. So x is approaching to 5 from the left of 5. So you will pick some number on the left of 5. Let's say you could pick a number 4.99. You could pick a number 4.98. So this is the meaning of the limit of the function when x is approaching to a minus. This limit is called left hand limit, and this limit is called right hand limit. When x is approaching to some number from the right of that number, that is the right hand limit. When x is approaching to some number from the left of that number, that is the left hand limit. In the next video, you will see some more examples of how to find the limit of a function at a point.